start calculating. Let us see whether it records. Okay, ammonium hydroxide is the one. Okay, now let us go to other one. A normal salt of sodium formed from acetic acid. This is very easy. Okay, this is a salt formed by an acetic acid. This is a salt formed by a normal salt of sodium formed by a acetic acid. So that means, so acetic acid plus sodium hydroxide, as this one, acid plus base gives the salt, right? So here this is the acid plus base will give you salt and water. This is our well-known universal equation. So in this he says that there is a normal this one, a normal salt of sodium formed from acetic acid. So here instead of in acid he takes acetic acid. Acetic acid he takes. Here he takes a base from which he forms a solution. He forms a salt. Which base he takes it? Because he is going to form a sodium salt. So I have to take a sodium base. Sodium base is NaOH. I will take it. That is sodium hydroxide. Then this will form into what? Let us see from the equation. Say for example, what is the acetic acid? Acetic acid is CH3COOH. Am I right? CH3COOH. This is the acetic acid. And when this reacts with this, also we have seen it actually earlier in the equations. When this reacts with sodium hydroxide, so what you will get it here, this will form into two ions actually. Acid will give two ions, this also will give two ions. Which are the ions this will give? This will give, definitely this has to give one hydrogen ion, hydrogen plus ion, because acid means what? Acid will always give a one hydrogen ions. So once it gives one hydrogen ion, then the remaining CH3COO will be a negative ion. Okay, will be a negative ion. Here also the base also will be ionic compound. So it gives one metallic positive ion, that is a sodium ion, and OH negative ion, that is a hydroxyl negative ion. Now they will replace each other. And then what is the equation you will find? This Na will go and join with this positive thing. So it is CH3COO. Now H is replaced with Na. So here you will get Na. And then you are going to get H plus OH will become H2O. So this is a salt actually. This is a salt. This is known as a acetic sodium, sodium acetate we call it as. Sodium acetate. Sodium acetate is a salt. CH3COONA. Sodium acetate is a this. So this is the normal salt. This salt is formed when acetic acid and sodium hydroxide
in the change room before the game. One of the players.
Very good. Okay, now let us go to the C. So C is what? C says that a base which reacts with an acid to give salt, which hydrolysis gives a slightly acidic solution. Which is the base?
But also ammonium hydroxide only, right?
Exactly. This also is ammonium hydroxide, because on hydrolysis it gives a slightly acidic solution. Okay, it gives an acidic solution when it is there. Okay, so that is also right. What you said is right. Now next one, D. An ion which combines with a polar covalent molecule to form ammonium ion.
If
Okay. Which is that ion?
Hospital, if I lose Dr. Lim and Dr. Park and Leah,
okay, someone is talking at the
I don't
background.
want to work there anymore.
Okay, an ion which combines with a polar covalent molecule. Okay, so which is that ion which combines with the polar covalent molecule?
Okay.
To form a ammonium ion.
Let's write that speech to the pension fund. I will do that alone.
So it is nothing but a
It's
hydrogen
terrible.
ion which combines with a polar.
So someone's audio is unmute.
Yeah, someone's audio is unmute. Can you mute the audios? So there is some background call that is coming up actually. An ion which combines with a polar covalent molecule to form a ammonium. it is nothing but H plus. H plus when it combines with the ammonia, then it becomes ammonium ion. Okay, this is the one, an ion which combines with a polar covalent molecule and forms a ammonium ion. So that's how it is. Now, a soluble salt formed by a direct combination between light metal and greenish yellow gas. Greenish yellow gas. Which is the light metal? So the light metals, if you can see, iron, copper, you know, so many metals, right? Among all these, the light metal is the aluminum is the light metal. That's why we use the aluminum for, even for making the aeroplane body, they use the aluminum. Why? Because it is the light metal, right? So aluminum is the light metal. And now you have to go to greenish yellow gas. Which is the greenish yellow gas? It is
Sir,
nothing but
chlorine.
chlorine. Yeah, chlorine is the greenish yellow gas, is the chlorine. Okay. And they will directly form. I mean, there is a direct combination. I told you what is meant by a direct combination. Here, one element combines with another element to form a salt directly. Okay. That is, aluminium plus chlorine will form aluminium chloride. Aluminium chloride is a metal chloride. Metal chloride is a salt. Okay. That forms a salt. Okay. So that is to tell you, that is, so aluminium plus chlorine will become a aluminium chloride. This will directly will be good. That is Al plus Cl2. Okay. This is the reaction that gives Al plus Cl2 will directly form Al. This aluminium valency is 3, so it will form Cl3. Aluminium chloride is Cl3. Aluminium valency is 3. That's how aluminium chloride, because aluminium is in the third group, 13th group. So thereby it forms this aluminium chloride. So to make this happen, so you have to make this 2Cl2, this is 3, and here you have to make it as 2. So that's how you can equate the equation, right? So
Sir, can you just repeat the D answer?
D, an
Yes, sir.
ion which combines with the polar covalent molecule is H plus ion,
Yes, sir. Okay.
hydrogen ion that combines with the ammonia and forms an ammonium ion. Okay, that's it.
So we don't need to write the formulas for all this,
No,
right?
here
Only
he is
the thing
asking.
is,
This is only
only
one
the
mark
name is
questions.
enough.
Yeah, you have to just write. You have to just don't write just hydrogen. You just write if you have a time, because this is a chemistry. This is not a something like a, this is these are not MCQ questions also where you write only A B C D and leave it. Try to, if you have a time, try to make one sentence, because one mark has to be given, right? Normally in chemistry, you take it from me, if there is a 1 mark question, short questions or anything like that, you need to write at least 2 or 3 sentences. Then you are sure that 1 mark question will come. Okay. Or minimum you write at least one sentence. Okay. Don't write one word. Try to avoid it. If you don't have time, it's okay, but try avoiding it. So you should write hydrogen ion which combines with the polar covalent to form ammonium ion. So it is the hydrogen ion. That's how we have to say that.
Sir, so will we lose marks if we written only one word?
No, that presentation doesn't look good. It is like when I ask you what is your name, you can say Rajat. That is a very informal way of saying it. But in exam, you are not a informal. Exam is a very formal way of writing everything, right? You can't write anything informally. Like I am teaching you so many things informally here because we are one to one. So it is okay. But there, it is not like that. There, you got to be very formal in the sense. What happens when I ask you what is your name, what do you say very formally? If you have to say, you say not Rajat, you will say my name is Rajat, you say. So even first one is not wrong, but it is a very formal. Second one is a very informal. Okay, sorry,
Okay, sir.
other way. So try to be formal, presentation has to be good, and it's it. And one more thing, see, whether it is for the exam or not and everything, in the education what you are learning, all this is for how you are going to present yourself in the real world. Okay, that's what you have to learn in an education. Because in education, when you go to either do a business, or you are going to be whatever you are going to be, either a businessman or a self-employed, or otherwise if you are employed somewhere else, what it makes to be successful, what it takes is always your presentation, your communication, your interpersonal interaction with the people, all that matters, right? All that matters. And there was a study that says that your way of interaction, making reports, making presentations, making formal presentation, informal presentations, and making yourself, I mean, your verbal communications, your written communication, all that matters. All these are the skills, all that matters are your interpersonal skills, how you behave with the people, all this matters a lot. And this matters almost all, they say that this matters almost all 80%. And your education, what you are taught in the colleges, schools and everything, may matter only 20%, they say that. Thereby we have seen, and in the world, you take it from me, not that all the first rank holders have done very well in the corporate industries. No, it is not like that. Maybe they will get the jobs fast because their marks are good, they will be able to enter well and everything. But after 5 years, 10 years, 15 years of experience, it is only the performance that counts. They will not ask you after 15 years, no one will ask you, oh, you were a gold medalist, is it? They will not ask you at all. Actually, they will wonder. We have seen some people, they were gold medalists from the best of the best colleges, and then after 15 years he is not able to perform well, and he is still a very low position, whereas the person who is a, maybe I don't want to use third class, but maybe the person with the lower marks has come and become his boss and other thing. At sometimes we will wonder, actually, oh, is he the gold medalist? It doesn't look like that, we will say, because gold medalist means we expect him to be a very bright and that this and all other thing, but he is a very bookish guy. He doesn't have all these skills and other things. So that's thereby, actually, these days they are giving more importance to how you present the things. That's also there. So you need to learn that more than that. Actually, if you get 1 or 2 marks less, it's okay, but you should learn all these skills so that you are ready for the world. You are ready for the world, and you will be successful in the world. That is most important. So try to learn the presentation skills when you are presenting yourself in the paper. So in the paper, when I see you, I should be able to see the way. Some of you are able to write very good. I really appreciate that. But some of you have to improve a lot, and some others improve a little. So anyway, that room for improvement is already there. Okay, all right, let's go to the match the descriptions to terms. It is very, very simple. This one, can anyone try the first one?
Sir, first one is monobasic acid.
Very good. So an acid having basicity 1, here only it said that any acid having basicity 1 is a monobasic acid. Okay, so with this, actually, this one will go away. Let me take the red color. Yeah, so monobasicity is gone for the first one, right? Very good. Okay, an acid which dissociates to give a low concentration of hydrogen ions. Any acid which gives a low concentration of hydrogen ions is what? It is a weak acid, because it is giving a low hydrogen. So high hydrogen atoms, that means high amount of hydrogen ions, that means it is a very strong acid. If it is a low hydrogen ions, I was telling you some of the acids, how they behave. An acid like HCl, if I take 100 molecules of HCl and put it in water, it immediately dissociates and give me 100 hydrogen plus ions. That is positive hydrogen ions it will give, and that will convert itself into hydronium ions, 100 hydronium ions. But some other acid which is a very weak, if I put that acid, that will not give you all this 100. If I put 100 molecules, it will not give 100. It will give lesser than 100. Actually, it will give maybe acetic acid or something like that. I take it. It will give only, if I put 100, it will give only 20 hydrogen ions. So thereby it is a weak acids. Those are the weak acids. So next, third one. Hope you are clear about the second one. Let us go to the third one. An acid containing hydrogen and non-metallic element other than oxygen. This is an acid which is containing hydrogen as well as non-metallic other than oxygen. Okay, that means it is not containing oxygen. any acid which is not containing hydrogen oxygen. Okay, it is containing oxygen also. Okay, non-metallic element other than oxygen. So no oxygen here. It contains only one hydrogen and one non-metallic element. What are these acids? Say for example HCl. HCl contains only one hydrogen atom, and this is a chlorine is a non-metallic, another non-metallic. Okay, that's all. It does not contain oxygen. No oxygen in this. No oxygen in this. Whereas I'm giving you another example. Say for example you take H2SO4. H2SO4. This contains one hydrogen atoms and one non-metallic, that is a sulfur, as well as it contains oxygen, hydrogen, oxygen, and one non-metallic. Okay. So what are these acids are called? The ones first one which does not have oxygen are called as hydroxides, which is known as hydra acid. Here A, which is known as hydra acid. If this is called as hydra acid, the one which is containing oxygen is known as what? Does anyone remember? Just hold up. I will have water and come. Acids are classified as many ways of classification of the acids we have seen it. One of the classification we saw is it was known as a hydra acids, strong acid, strength of the acid, and another one is oxy acids, alkalis, bases, simple division, monobasic, tribasic, petroleum, hydroxyl, acidic oxides. Oxy acids, other one is known as oxy acids. The one which contains the oxygen is known as oxy acids. Okay. Now let's go to the fourth one. Type of acid which generally displaces another acid when the acid is heated with the salt.
Sir, fourth one, right?
Yeah, fourth one.
Sir, I think it's more volatile acid. I'm not sure.
More volatile?
No, it is always less volatile. So with the less volatile acid will always replace the more volatile acid. Okay, so it is type of acid which generally displaces the another acid, means less volatile acid will replace the more volatile acid when it is heated with the salt. Okay, it is less volatile acid. C. Okay, fifth one, let's go. The type of acid which reacts with a base to give an acid salt and a normal acid salt and a normal salt.
Sir, I'm pretty sure this should be strong acid, but it's not given.
It gives two salts actually. Here you see that type of acid which reacts with a base to give an acid salt as well as a normal salt. Both the things it will do. That means this must be a dibasic acid. It must be a dibasic acid. Why? Because the dibasic acid will give you two hydrogen ions. One hydrogen ion will form one salt. Another hydrogen ion will go and initiate the other salt. That's how it is. So it must be a dibasic acid. It must be a dibasic acid,
Okay, sir.
which will give you the two salts. It will give you. Let's go to the match the following. PbCO3. Preparation methods. Okay, before understanding the preparation method, in the earlier chapter also we saw you should try to understand what is the how the solution, I mean the solubility of the salts you should understand before understanding the preparation. Then that will give you some kind of a reference for the how the preparation happens and other things. Okay, solubility of salts. Let us understand the solubility of the salts, which I have told you earlier also and which is there in your book also. Let me show you that. Okay, solubility of the salts. If you take solubility of the salts, normally you take any salt. Okay, normally what is a salt? Salt contains a metal. These are all called as metallic salts and the non-metallic salts. So let us go over any salts which contain sodium, potassium and ammonium. Please remember these three. Any salt which contains sodium, potassium and ammonium. Okay, these salts are 100% soluble, always soluble. These are 100% soluble. Any salt which contains sodium, potassium, ammonium is always soluble. That's the one thing should remember. Okay. Next. Next is like any salt that contains anything that contains sodium, potassium, ammonium is always soluble. That is one thing. And any other rule that comes will go. This is the first and foremost rule that you should remember it. Okay. And always again thing you should remember that this solubility of salts when we are discussing for the cold water, normal water. Okay, that's how it is. Okay, and anything all nitrates and nitrites, nitrites. These are all nitrites. So these are all soluble. Okay, so these are all soluble, but except you got there is no exception for this. Sulfides, carbonates, hydroxide are soluble. Okay. And then all bicarbonates are soluble. All bicarbonates are soluble. But there is an exception to this. That is very important. Exception is potassium bicarbonate. Potassium bicarbonate is written as CO3 and sodium bicarbonate. These are not much soluble. These are not soluble. Okay, this is not soluble. And all sulfates are soluble except, you should remember exception, except lead, that is a Pb, lead, silver and then calcium and beryllium. These sulfates are not soluble except Pb, Ag, Ca and Ba. These are not soluble. Okay, this you should remember. Similarly, all chlorides are soluble. All chlorides are soluble again except Pb, silver Ag, and here you get Hg. These are the three things. So these salts, these chlorides are not soluble. Okay, 1, 2, 3, 4, 5 rules I have told you about this. Please remember these 5 rules, general rules about this. Okay, these are the general rules about this. Okay, so this way we can make out what all the things. Say for example, here in this, okay, we did this. Now let us go to what he has given. He has given PbCO3. Okay, here carbonates is not given, bicarbonates is given. Carbonates is not. Oh, all carbonates are okay. Here, sorry, sixth one is also there. Here, all carbonates are insoluble, but except except these three: sodium, potassium, and ammonium. Except sodium, potassium, and ammonium, because I said that anything that contains sodium, potassium, ammonium are soluble. So therefore, even if it contains carbonate, carbonate means CO3, anything ends with CO3, anything ends with CO3 is insoluble except sodium, potassium, and ammonium, right? This is the thing. Now he has asked you to find, let us go to this. He has asked you to find PbCO3 salt. How can you prepare a PbCO3 salt? Now, PbCO3, first and foremost, you know that this is insoluble, because any CO3 except sodium, potassium, and ammonium are insoluble. So, this is PbCO3. So, this is insoluble in water. That is what is meant by insoluble in water. When you put it in water, this doesn't dissolve. It will form a lump and it will settle at the bottom of the flask or the test tube, whatever, wherever you are doing that. Actually, it will settle at the bottom. So it is insoluble. It will not dissolve in the water, and it will not make itself a true solution. Like when you add salt to the water, it will become a true solution. You will not be able to find where is water, where is salt. That's how it will gap. So same thing, PbCO3 doesn't go like that. Actually, it is insoluble. So thereby, when you want to make PbCO3. So normally the salts are made by the double decomposition only, because this is a Pb, this is a Pb. Pb is always in the reactivity series. You remember the reactivity series what we had in the last year? Does anyone remember? So in the reactivity series, let me see if there is a reactivity series anywhere. So there is no reactivity series in this. In the reactivity series, normally the Pb is above the hydrogen. Pb is above the hydrogen. The ones which are below the hydrogen, Pb, zinc, sodium, potassium, calcium, all these are above the hydrogen. Above the hydrogen. That means H can replace, I mean, these things can replace the H. When you say in the reactivity series, these are all above. That means all these fellows can kick out the H from the acid. So thereby, if I take an acid, say for example, I am taking an acid like if I take Pb with a let me make a PbCO3. One moment. Pb plus HCO3 I have to do. So when I take Pb plus HCO3 I take. So this Pb will kick out the hydrogen, then it will form PbCO3 plus hydrogen will evolve. And this reaction is called as, since this PbCO3 is insoluble, so this reaction is called as, and this will PbCO3 that is formed, that will in SCO3 liquid, no, that will precipitate at the bottom. So it is known as, and this is known as, and balance HCO3 becomes CO2 and H2O also. So that PbCO3 is a simple displacement. This will become a simple displacement. Sorry, this will become a precipitation. Sorry. This is known as a precipitation by displacement method. Precipitation double decomposition. Sorry. Precipitation double decomposition method. I'll take PbO because this is PbO plus Pb. So it is PbCO3 plus H2O. Okay. In the water it precipitates. So this is known as a simple, this is known as a precipitation double decomposition.
Sir, can you also mention where it is in the textbook so that we can learn it?
What is that?
So can you also mention where it is written in the textbook so that we can also learn it?
This one?
Yes, sir.
Okay, let me check. I don't know whether it is, because some of the things I'm not referring to your textbook. So displacement, precipitation. Okay. If you go to page number 50 in your textbook, especially in yours, I will tell you, Yashaswini, for you also. If you go there, so there it is precipitation by double decomposition, but it doesn't give this particular one. PbNO3 he gives. Mm,
Yes, sir. That's why I got confused because I'm not sure if it's written.
it is not written here. PbCO3 precipitation. You can see if you continue there in the next one in page number 51, example 3 he has given. Okay, he says that how to convert PbCO3. Okay, he is not telling how the PbCO3 is formed. Okay, sorry for that. There also he has not given. PbO plus HCO3 he has not given. Okay. Okay, I will send you another set of reaction list of reactions so that you will be able to find out there. Okay, I will try to send
Sir,
it.
I wrote only the letters for the match the following because I didn't have time. Is that okay?
It's okay. Actually, even if you write the letters also, it's okay. You need not have to write everything actually, but you should write the letters properly. Okay, that's how PbCO3 is a precipitation and a double decomposition. Precipitation by double decomposition. That's the one thing. Okay, let
Sir,
us
but you said
continue.
it's simple displacement.
No, no, it's not a simple displacement. It is going to be uh, because it is PbO. Here I said that it is going to be PbO plus HCO3. So here what happens? PbCO3 will form, that is a salt, and H plus O will form H2O. Here you need to balance the equation, of course. So here it is a double decomposition, and here the PbCO3 will precipitate in the water that is formed. So thereby it is very easy. This PbCO3 can be decanted, and once you decant the water, you will get the PbCO3. That's why we call it as a precipitation double decomposition method. Actually, this is known as PbCO3 is known as a precipitation double decomposition method. Okay, that's how it is. Okay, now let's take the other one, zinc nitrate. Okay, when you say okay, zinc nitrate, if you take it, this is going to be, this is a active metal. Zinc is an active metal. Why it is called as active metal? Because it is above the hydrogen, and HNO3. Here we are going to take Zn plus HNO3. Zn plus HNO3. Then you get zinc nitrate plus H2 gas evolve. Whenever there is a active metal, when it reacts with a dilute acid, any dilute acid, when it reacts, it immediately forms a salt ZnNO3. So it will displace the hydrogen. Okay, so then you get, similarly you get H2SO4 also. When you have got a dilute sulfuric acid, you get that actually. So this is known as a C. Actually this comes here. It is a simple active metal with a double displacement. Active metal
Sir,
with a
but
double.
in my textbook it's written as neutralization.
No, it is not neutralization. Neutralization comes with the third one, right? That is
Yes, sir, but in my
NaCl.
textbook it's written action of dilute metals. Sir, action of dilute acids on active metal, on carbonates and bicarbonates.
No,
Under that,
neutralization.
it's
For me, neutralization is like this one B. Here it is. Third one is for the B, because neutralization NaCl is always formed when you have got a acid plus base. Okay, then you form NaCl. How is the preparation of the NaCl is done? NaCl is done by a neutralization process of acid and the base. And what are these acid and the base? This is alkalic acid and this is a dilute acid. So when you make this, then you will get a NaCl plus water. This reaction is called as neutralization reaction. So NaCl is formed by this neutralization. reaction. Whereas Cu, this is a copper nitrate. Okay, copper nitrate, again this is the same thing. This is formed here also, it is same to same. It is by neutralization by a insoluble base and a dilute acid. Okay, insoluble base and a dilute acid. Which is a insoluble base? Here you are going to take a CuO, copper oxide is an insoluble base. And which is the dilute acid you are going to take? HNO3. It is a dilute HNO3 you are going to take. Okay. Then when you take this, what you will form? You will form copper nitrate, CuNO3. Since copper is a 2, valence is 2, I am going to write it like that. And what is remaining? H2O is remaining. So that's how this forms, copper oxide and HNO3. So this copper and nitrate will form and H and O will form a water. So this is also a neutralization reaction only, but this is an insoluble base. Normally all the bases, you know what is a base? We said that metal oxides, metal hydroxide. What is a hydroxide? Is generally soluble in water. Hydroxide is generally soluble in water. Normally, it is a normal. I am telling you mostly actually. Normally, oxides are not soluble in water. Oxides are nothing but when you burn the copper, you get copper oxide. This copper oxide is in the powder form normally. And this powder, when you add it to the water, it will not get dissolved. So thereby we call it as an insoluble base. This is called as an insoluble base. This is a base, but it is an insoluble base. And what is the insoluble base is called as base one. Okay. What is a soluble base is called? It is called as alkali. Soluble base is called as alkali. Okay, that also we are saying. So this is a non-alkalic base. So we call it as insoluble base and dilute. This is how it is. So in your book, if it is written as something different, then that must be wrong. I will also check one more time. But as in my opinion, NaCl must be B and CuNO3, that is a copper oxide, which is should be A. Okay, and the last one that is remaining is D only. So this also is directly given only. FeS is always equal to D. FeS is always why? Because ferrous and sulfide, when you combine them, so it will form a direct combination method. So if you get ferrous sulfate, which is a solid actually, ferrous sulfide is a salt, sorry, which is a salt. So this is made from a element plus element. Both elements will combine together, form a ferrous sulfate. That's how it is. Any doubts so far? This is the one which you are telling you had most of the doubts. So I spent a little more time to explain you. That's it. So fourth one is a very easy one. You have to just give a balanced equation for this. Hope you might have done it properly, right? In case you need any help, please do let me know. I will do that actually. Calcium oxide plus calcium hydroxide.
Can you do the fourth one?
Okay, let us do that. I will try to take this so that it is easier for me.
Oxide.
Okay. Okay. Let's start with calcium oxide. Calcium oxide means what? CaO, right?
Yeah.
CaO,
That's
calcium oxide, will give you calcium chloride.
H2O.
Balanced equations for preparation of following salts. So what you are going to prepare? You are going to prepare the calcium oxide, and from calcium oxide you have to get a calcium chloride. You have to get calcium chloride. So to get a calcium chloride, what you have to add here? You have to add HCl. Am I making my point? Okay. When you add CaO plus HCl, this is the one which is the addition. CaO plus HCl, you get a calcium chloride. So from calcium oxide, if you want to get a calcium chloride, this is the equation. Calcium oxide plus HCl is equal to calcium chloride plus what is remaining here? H and O is remaining. H and O will form into H2O. This is the first equation, right? A1. A1 first equation. Then from calcium chloride, you want to get a calcium carbonate. From calcium chloride, you want to get a calcium chloride. Now I have got a CaCl2, ClCl2, and I want to get what? I want to get a calcium carbonate, CaCO3 I want to get. Okay, let us try to equate this equation because he said that balance the equation also. Let us
Sir, first one is not balanced.
okay. So it is
Two
only this.
HCl.
Yeah, add 2HCl, it gets balanced. Very good. That's right. Okay. Now, next one. CaCl2, add something here. So you get CaCO3. So to get CaCO3, you want to add, say for example here, and CaCO3, calcium chloride, right? You want to add. So better you add sodium carbonate or any metal carbonates you add it. So you have to add that carbonate which will replace the this one. I mean, you have to add highly active. See, in the activity series, potassium and sodium, and after that calcium is there. Okay, so you can only add if you want to replace the calcium from here. Okay, you want to kick out the calcium from here, you can use only sodium or potassium. Okay, now I am going to use sodium or potassium, that is sodium carbonate I am going to use. Or I could have used even potassium carbonate also. So sodium is Na2, that is CO2 is this one. So it is going to be Na2CO3, that is going to be done. So this will give you CaCO3 1 plus some more thing also it will give. What is remaining CaCO3 once it is done? What is remaining is NaCl. So I will put NaCl. So balance is NaCl is going to be 2 NaCl because 2 Na plus 2 Cl2. So it is going to be 2 NaCl. So this is the second equation in the A part. So A part equation we know from calcium oxide we got calcium chloride. From calcium chloride we got it calcium carbonate. That's how it is. Now let us try to go for B part. Now in big part he says that zinc sulfide. What is zinc sulfide? It is ZnS. Okay. Zinc sulfide, how this is made from the zinc? He is asking, this is the ulta arrow. Zinc sulfide from zinc and zinc sulfate from the zinc. So there are two equations. You have to tell from zinc to zinc sulfide how you get it. Very easy. From zinc plus the sulfur, if you add, you get zinc sulfate. Zinc sulfide, sorry, it is ZnS. Okay, it is known as zinc sulfide is ZnS. So this is the zinc sulfide, ZnS. So it's a direct combination. That's it. One thing you got it. Now you are telling that from the zinc you have to get a zinc sulfate. How you get? This is zinc plus you have to add something so that you get a zinc sulfate. What is zinc sulfate? It is nothing but ZnSO4, right? It is sulfate. Okay, ZnSO4. So what I have to add here? Naturally, I have to add an acid, which is a dilute acid, because this is the active metal. Active metal with any dilute acid will give you a salt and hydrogen gas. So I am going to add dilute hydrosulfuric acid, H2SO4. H2SO4. So then what is that? This becomes zinc sulfate and this hydrogen will get released, evolved from here, from this equation. So this is the B. There are also two equations in the B which we could able to
Sir,
do.
either it will have H2SO4 or HCl
No, HCl.
commonly.
No. If you put HCl, then you get zinc chloride here. But you need zinc sulfate here. You see here what you want from zinc. How do you make a zinc
No,
sulfate?
I'm not asking about this question, like common.
Common, yeah. Commonly they will ask you this only. So this is a single displacement reaction. This is nothing but an active metal reacting with a dilute acid. So what will happen? So this H will gets kicked out from here. Why H will get kicked out? Because zinc is more active than the H. Anything potassium, sodium, calcium, zinc, Pb, all these, there are about 7 elements are there. I am not able to remember all that now. So all these elements, even aluminium doesn't come. No, aluminium doesn't come. All these elements are above H, and there are about 3-4 elements below H. They will not replace the H. Even if you add, say for example, gold is below the H or titanium is below the H. Okay, Au, Ag, all this. Okay, if I take Ag plus H2SO4, this reaction will not happen. Will the reaction happens? No, it will not react because Ag will not be able to replace the H. Got my point? So that's how this reaction will not happen.
No,
Whereas,
sir, like if they have given, first you have to write the reactant one and product. Then we'll figure out it.
Yes, exactly. They have given one product and it is like a plus B is equal to C D, C plus D. But here what he has done is he has given you one A and one C. So this you have to find what you should add to this product to get this product plus so many other things. That's all. Okay. So I am giving one product. I want to make another product. So what do you want? You want something, what you want to do, make it actually. That's how it is. Okay. It is more like a fill in the blanks, I can say. Okay. Similarly, let us go to the iron chloride is made. How the iron chloride is made from Fe? Simple, right? This is a Fe. Then you have to add something here so that you get iron chloride. What is iron chloride? FeCl2, because iron has got 2 or 3 is the valency, but here we take 2 as a valency. So here it is iron chloride is a FeCl2 and plus something you will get it, you don't know. So now what I am going to add here to get FeCl? Naturally I have to add HCl, right? Because iron is also above H. Okay, this is also same like that, a active metal and a dilute acid, then it will give a FCl2 and what comes out here? Naturally H2 will come out here in the gaseous form. Okay, now he is asking another thing here. He said that iron chloride, here it was having a 2 valency, here 3 valency. Iron chloride with 3 valency, that means Fe uh, FeCl3, here it is. It is going to be FeCl3. How you can get FeCl3? From Fe only. So again same thing. You have got a Fe here plus you have to add something so that you get ferrous chloride. This is there in the book also. Okay, ferrous chloride directly. Here this will come when you can directly on a hot iron, when you pass the chlorine gases, it will become ferrous ferrous chloride. Okay, when it becomes ferrous chloride. So here to do this, what you have to do, this is 2Fe, this is 2Fe, this is 3Cl2. That's how you can equate this function. Here also you equate it with 2HCl. Got it? These are the some of the equation. You need to go through that, try to understand the logic behind it, and then understand it. When we do the revisions, we will try to do it much more. Actually, I will run through all the equations and try to give you the funda behind every equation, why that behaves like that and other thing. At that time, once you know your fundamentals properly, then you yourself will be able to know with what material how it will act. Okay, how these are going to react to each other and what it is going to form. Okay, that you will be able to know. This chapter that way is quite interesting to know all these things, actually behavior of all the substances and other things. Okay, similarly you have got a lead oxide from a lead nitrate. Okay, no, from lead oxide you have to make a lead nitrate. Okay, one, what you have to make, this is a lead oxide to lead nitrate. What is a lead oxide? Lead oxide is nothing but PbO. What is a lead nitrate? This is Pb NO3 2. Okay, because lead is having a 2 valency. Here also lead is having a 2 valency. What will happen? Lead is also having 2 valency. Oxygen is also having 2 valency. So both will go like this, crisscross way. So Pb2O2. So Pb2O2 will become PbO only. Okay, most of the cases where the valencies are same, they will cancel and it will become PbO. That's how this is plumbous oxide, we call it as, or otherwise a lead oxide, call it as. Here also, here it is having 2 valency and NO3 is having 1 valency. Why? Because HNO3, no, its ability to combine with hydrogen atoms, NO3 is having only one ability to combine. So 1. So 1 will go here, 2 will go here. That's how this will become PbNO3 2. So that's how we know how the compound needs to be written and other things also we have learnt in the last classes. Again, I am repeating it so that you don't miss it anyway. So now from PbO, how to make a PbNO3 2? Very simple. PbO. This also we wrote sometime back. PbO plus HNO3 will give you PbNO3 2 plus what you will get? The remaining is H and O. So you get H2O. So once you get H2O, so try to see NO3 is 2 and H2 is 2. So you put 2 here, so it gets equated. Getting my point? Right. So now let us go to the other one. From lead nitrate to lead sulfate. Now you got a lead nitrate, PbNO3, you got it. Now from PbNO3, you have to get a PbSO4. So PbNO3 2, you have got it already. Now what you have to get? You have to get a lead nitrate and lead sulfate. PbSO4 is lead sulfate. Now you have to choose here. You have to choose a metal which is active than the Pb. Okay, which are the metal which are active than the Pb? You can see all these metal which are active than the Pb. All above metal: calcium, potassium, sodium, zinc. All these are above Pb. So let me take something like a sodium. I will take it. I will take a sodium, which will get replaced by Pb. But what sodium I have to take? Since I need a sulfate, so I will take a sodium sulfate. I will take it. Okay, I will take sodium sulfate, which is Na2SO4. I will take it. So then, what will happen? This formed a PbSO4, and what is remaining? Remaining is NaNO3. NaNO3 is remaining. Okay, this NaNO3, I am going to keep it here like this. So let us balance this equation. So PbSO4 is okay. NO3 2, Na2 2. So I put 2 here. This gets balanced. So this is the this one. Okay. Next, let us go here. What is asking? He is asking copper oxide to copper sulfate. Can anyone do this? What is a copper oxide? He is asking copper COPPER, copper oxide, or it is called as cuprous oxide. Copper oxide to what is it? Copper oxide to copper sulfate, right? Yeah, copper sulfate. And here he has put this as a 2. Here also it has put 2. That means valency of copper is 2. Okay. Now let us do. Now tell me what is a copper oxide formula? Can anyone tell me copper oxide? One is a copper, another one is oxide, right? Oh. And if you know copper and oxide, what is the valency of copper? He himself has given it is 2. And what is the valence of oxygen? We know it is 2. Okay. So when it goes here and here, 2 and 2 will get cancelled. So it becomes CuO. Copper oxide is nothing but CuO. Are you clear about this? Very good. Now copper sulfate. So again you put Cu and sulfate is SO4. Sulfate is SO4. And here, what is sulfate valency? It is 2 because H2SO4, it is 2 hydrogen atoms, so it is 2. Again, copper is also here 2. So when it is going like this, 2 will get cancelled. So it becomes CuSO4 only. That's all. Got it? Are you clear? Okay. Now, how do you get a Cu from CuSO4? Very simple. Let us go here. CuO plus, you have to get a SO4, right? Best way is you add H2SO4. Then what will happen? This Cu will replace the H2 here. So it becomes CuSO4 plus H2O. That's it. Simple. Okay. The last one we are going to go ahead with. From copper sulfate, you have to get a copper hydroxide. Now I have got a copper sulfate, which is a salt. Copper sulfate is a salt. Now I have to get a copper hydroxide. Copper hydroxide means what? It is nothing but it is other way actually. This mark is given this way. Okay. From copper hydroxide, you have to get a copper sulfate. instead of copper oxide.
Sir, I think in my test I've missed the arrows. I think I put it the other way.
Yeah. So no, here also, if you know, this is a base. That's why I also got confused, because base plus acid is equal to salt. From the salt and acid, you will not get a base. That's why I was wondering. So it should be a copper hydroxide, CuOH, and here again, this is 2, this is 1. So when it crisscrosses, it becomes OH2. Okay. And this fellow is a base. Copper hydroxide is a base, and base plus acid, I want to add a acid here so that I get a CuSO4. So what acid I can add? Same thing, I can add H2SO4 again, H2SO4. So here I get CuSO4 plus H2O. So either metal oxide is also a base, metal hydroxide is also a base. Only thing is that this is a base and this is an alkali. This is a insoluble base and this is a soluble base. These are the only difference between these two bases. This is a soluble, this is a soluble, this is a insoluble. But whether this is soluble or insoluble, when you are diluting with a dilute sulfuric acid, you will get this. And here you are taking a normal acid, H2SO4 you take it, so you get CuSO4 and H2SO4, and both are neutralization reactions only, in which acid plus base, when they combine, they will give you salt and water. These are the neutralization reaction that will give you all these things. Okay, that's it. With this we completed the reactions and other things about the salts and other things. If you want to know little more about that, I can take one more class if you want, and I can explain you how the salts are classified, how the salts are, or otherwise when I am doing the revision, definitely I'm planning to do that actually. Okay. So next class, I intend to go through question answers of Selena. Is that okay for you all?
Yes.
Yes, sir.
Yeah, we will go through the question answers of Selena, and also, and next time during the revisions, I will go through the question answers of all the previous years, which is already there in your which book? The Dalal book actually. It is there in the Dalal book. Okay. So, but anyway, I will go through the question answers of Selena. Question answers of Selena are comparatively little simpler and easy to understand and other things. Hopefully, we will be able to do well in the question answers of Selena. Okay, right then. And if you need question answers of these things also, let me try to do that and then try to send you. Or otherwise,
Sir,
I'm
one more
going to send
thing.
you the notes. Yeah, tell me.
Sir, you told that June test, right?
Yeah, June test, right.
You will be taking it in month of June.
In the month of June, somewhere in the mid of June. That is exactly 3 weeks from now onwards. And
So
I'm
because in that time we'll have CT1 or something. So
oh, is it okay? Then I will try to do that before that. Maybe June first week I will try to take it.
okay.
Before your CT starts. When is your CT starting? 10th June, is it? 15th June.
Not yet received, sir. Actually,
Okay, anyway,
uh,
then I will try to do it in the June 1st only. I will send you in the next 2-3 days. I will send you the portions which I am going to keep it for you. Normally, all the portions I have done so far only I am going to do. Next 2-3 weeks, whatever portions I am going to do, I will not include in that. Okay.
okay.
Okay. Then. Right.
Okay,
Any
sir.
doubts or this one clarifications you
No,
need?
sir.
No. Okay. Right.
No, sir.
Okay then. Bye bye.
Thank you.